Water has always shaped our world, carving valleys, nourishing crops and sustaining life. But for thousands of years, humans have done more than just survive by the water. We've harnessed its power. From ancient water wheels to the towering dams of today, hydropower has been a cornerstone of civilization's progress. This is the story of hydropower. Hydropower didn't begin with electricity. It began with movement. Around the 3rd century BC, ancient Greek engineers developed the first water wheels. These vertical wheels were turned by river currents to grind grain into flour, saving hours of manual labor. By the 1st century, the Romans had industrialized the idea. In southern France, the Barbagal mills used 16 water wheels in a cascading system to process grain for an entire city, one of the earliest examples of mechanized industry. In China, hydropower spun silk, processed rice, and drove bellows for metallurgy. These early systems harnessed the motion of water to fuel human productivity. The Industrial Revolution brought coal and steam, but water stayed relevant. Factories in Britain and America were built beside rivers, using massive wooden wheels to power textile looms and sawmills. But the real breakthrough came in the mid-1800s. In 1849, James B. Francis, an engineer in Lowell, Massachusetts, invented the Francis turbine. It used curved blades and pressurized water to spin faster and more efficiently than old-style wheels. It was compact, powerful, and reliable. This turbine remains the foundation for most modern hydropower systems, and it made something new possible: the generation of electricity. In 1882, a small hydroelectric plant opened along the Fox River in Appleton, Wisconsin. It powered a paper mill and 2 homes, the first commercial use of hydroelectric power in the world. Soon, hydroelectric plants sprang up along rivers across the United States and Europe. They lit streetlights, powered factories, and brought electricity to towns, all without burning fuel. Water, flowing downhill, could now generate power for entire communities. So, how does it work? A typical hydroelectric system has 3 main parts: a dam to control water flow, a reservoir to store water, and a power plant where electricity is produced. Water from the reservoir flows through an intake and into a penstock, a large pipe leading to the turbine. The force of the water spins the turbine's blades. The spinning turbine drives a generator. Inside, magnets and coils convert mechanical energy into electrical energy. The amount of electricity depends on 2 factors: the height of the water drop, called head, and the volume of water flow. Once through the turbine, water is discharged back into the river. The electricity travels along transmission lines to homes, factories, and cities. By the early 20th century, hydropower was ready to go big. In 1913, the Keokuk Dam on the Mississippi River was one of the world's largest. But the turning point came in the 1930s, in the middle of the Great Depression. The US government launched massive infrastructure programs under President Franklin D. Roosevelt's New Deal. One of them was the construction of the Hoover Dam. Built on the Colorado River, Hoover Dam was a symbol of modern engineering. Over 20,000 laborers endured extreme conditions. Shifts ran around the clock in the blistering Nevada heat. Many lived in makeshift camps or in the newly constructed town of Boulder City. Innovations included the use of massive cableways to pour concrete in precise forms, and a system of diversion tunnels to reroute the Colorado River while the foundation was laid. The dam required over 3 million cubic yards of concrete, enough to pave a road from San Francisco to New York. It also marked the first major federal project to include a power generation component, shifting the role of government in infrastructure and energy. Shortly after, the Grand Coulee Dam was completed in Washington state. Today, it remains the largest hydroelectric power plant in the United States, helping Washington generate over 2/3 of its electricity from hydro. By mid-century, other nations were following the American model. Canada built massive plants in Quebec and British Columbia. Brazil began tapping the Amazon and Parana rivers. The Soviet Union and India built large-scale dams for power and irrigation. Then came the giants. On China's Yangtze River, the Three Gorges Dam was completed in 2012. At 1.4 miles wide and over 600 feet tall, it became the largest hydroelectric plant in the world by capacity, producing 22.5 gigawatts of power. But it came with cost. Over 1.3 million people were relocated, towns and temples were submerged, and ecosystems were changed forever. Meanwhile, the Itaipu Dam, built between Brazil and Paraguay, often generates more total electricity annually than any other plant, thanks to steady flow and efficient operations. Hydropower isn't just dams and rivers. There are multiple forms of water-based energy. For example, tidal power uses the rise and fall of tides to generate electricity. Turbines are placed in estuaries or coastal channels, turning as water flows in and out. Unlike solar or wind, tides are consistent, making tidal power a reliable source of baseline energy. Today, hydropower generates about 16% of global electricity, and it remains the world's largest source of renewable energy. In Norway, nearly 100% of electricity comes from hydro. But the future is changing. Climate change is altering water cycles. Large dams face criticism for displacing people and damaging ecosystems. Many countries are now focusing on smaller scale, lower impact hydro solutions. The future of hydropower lies in smart integration, working alongside solar, wind and batteries to create clean, flexible energy systems. From ancient water wheels to ocean-powered turbines, hydropower has fueled human progress for more than 2,000 years. It's clean, it's powerful, and in a world searching for sustainable energy, water may still hold the key. Thank you for joining us on this journey through the history of hydropower. If you enjoyed this video, please like, subscribe, and hit the bell icon for more deep dives into fascinating topics.